Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we derive an equation for the change in length of a tapered bar of circular cross section. Okay, in the previous videos we have done some numericals which belongs to the constant cross sectional areas, constant cross sections. But today in this video we derive what will be the equation for the change in length for a circular cross section of a tapered bar. Okay, let us consider some construction part here. Now this is the member what I have taken, which is of a circular cross section of a tapered bar. So now this is the diameter of a tapered bar varies from small d1 to d2, which is having a length L and it is subjected to a load P here. Okay. Now this is what I have given here. Now before deriving here, let us consider just what I'm considering here is consider a tapered bar of a circular cross section whose diameter varies from d1 to d2, which is having a length L and it is subjected to a load P. Okay. Now this is what we have given here. Now before deriving here, I need to consider small differential element. In this case I have considered this as a small differential element. So for that differential element I will try to find out what will be the change in length for that member. So after that, if I integrate with respect to from 0 to L, that is a given length here, I can get the total change in length in the member here. Okay, I will just consider the same here. Consider the differential element whose diameter is d dash, which is having a length dx here. Okay, you just see here, since the diameters varies linearly, we can able to write some relation between the diameters. That relation is, so since the diameters varies linearly, we can write some relation that, so it is given by d2 minus d1 by L is equal to d dash minus d1 by x. So how it is? So take d2 minus d1 by total length L, that is equal to d dash minus d1 by x here. So this is what the relation when the diameters are varies linearly. So from that, from this equation I will try to find out what will be the d dash here, because I have to find out the change in length for the elemental cross section, that is a small differential element. That's why I will try to find out what will be the d dash here. Just take this to the left hand side, just cross multiply. So this becomes d2 minus d1 by L into x, that is equal to d dash minus d1. Okay, again you just take this minus d1 to the left hand side, it becomes d1 plus d2 minus d1 by L into x, that is d dash here, that is the diameter of a small element here, that is a differential element. Now what will be the area? So I just take area of differential element is, so we know that area for the circular member is pi d square by 4. So I can take this is a pi by 4 d dash square. Okay. So just substitute what is the d dash here. This will be the d dash here. I substitute in place of d dash as d1 plus d2 minus d1 by L into x. So this is your d dash here and whole square we have to take. Okay, this is the area here. Now once if you find out the area, I will go for the what will be the change in length of the differential element. Therefore I will go for the change in length, that is delta L for differential element. For differential element is delta L I will take. So it's a element here. So what is the delta L? So we know that delta L is equal to PL by A, standard formula. I will just take with respect to same itself. So P means the applied load, the load is also same, that is applied load here. Now in place of L I will substitute this dx here, that is the length of the differential element. divided by, so A is there, that is the area of the element means I have to take this equation, that is the area here, that is pi by 4. So it is a d1 plus d2 minus d1 by L into x whole square. This is the area. Now again Young's modulus is the, I'll write the Young's modulus here. So this is the change in length for the elemental, that is a differential element here. Now if I just integrate this from 0 to L, that is the length here, I can get the change in length for the entire section here, that is a given entire member. I'll consider the same equation and I'll try to integrate. Okay, so therefore the change in length for entire member, that is for a given entire member, is delta L. I can take entire member is, because when I integrate from the left hand side part directly, I will go for the change in length for the entire section here after integrating. Now the right hand side part I have to integrate with respect to x, and the limit is varies from 0 to L. So this is p by pi by 4. So d1 plus d2 minus d1 by L into x whole square. So this is E with respect to dx. Just I have taken this equation. Okay. Now before integrating, take the constant terms outside the integral. So pi by 4 common. So pi by 4 is constant, E is constant, P is a constant. Take outside the bracket, that is the integral form. And again this 4 will go to the numerator. So it becomes 4p by pi E integral 0 to L. Just write the remaining terms here. So 1 plus d2 minus d1 by L into x whole square. So into dx. So this is, I need to integrate. We have a relation that, so suppose integral of 1 over x square with respect to dx is what? It's a minus 1 over x. The same way, so if suppose I am having a 3, so what I have to take? It's a minus 1 over 3x. The constant term should be multiplied here. So same way I have to integrate this term here. I'll just take somewhere here. You just integrate the remaining term as it is, so that finally you can able to get that equation. So it's a 4p by pi E. So when you integrate this, I am going to get minus should be there. So this is d1 plus d2 minus d1 by L into x. So limit is 0 to L, but again I need to divide the constant of the variable. So I'll divide here d2 minus d1 by L, that is a constant of this variable. Now after simplifying, so since this is somewhat the constant term, I'll just take outside the bracket before applying a limit. So this L will go to the numerator with p. So d2 minus d1 will becomes with the pi E. So this becomes 4p L pi E into d2 minus d1. Okay. So now the remaining terms are minus 1 over d1 plus d2 minus d1 by L into x. Now the limits are from 0 to L. Now for this term, now we have integrated this. Now we just apply the upper limit and the lower limit. So if you just apply the limit and just simplify, we are going to get a solution. Now this 4pl remain as it is, pi E d2 minus d1. So you just apply the upper limit first. It will be 1 over d1 plus. Now if you just substitute this in place x, L in place of x, d2 minus d1 by L into L. Okay, this is, we have applied the upper limit minus the lower limit I need to apply. So d1 plus d2 minus d1 by L into 0. So this is what we have applied the lower limit. Now the thing is, the LL get cancelled. So plus d1 minus d1 get cancelled. Since this term enters 0, it will be 0. The remaining term is 4pl by pi e d2 minus d1. So this is minus 1 over d2 will be remains here. So this minus into minus plus 1 over, so d1 will be remains. Now for this term, you just simplify by taking the LCM. Okay. So here what I am getting here, this is 4pl pi e d2 minus d1. Now if you just take the LCM, in the denominator will be having a d1 d2. So this d1 will be comes here, it becomes minus d1 plus this d2 will become somewhere here. Okay. So this is what I am getting here. Now this plus d2 I will write first, this minus d1 I will write second term for understanding. So plus d2 minus d1. So why I have taken? So that I can cancel these two terms. So this is the final what I am getting the solution. You just simplify that, just write in the, write that equation in a simple manner. So what I am getting here, it is a total change in length L is equal to the 4pl divided by pi e. So here only d2 minus d1 get cancelled, only the remaining term is what? It is a d1 d2. So this is the equation for a change in length of a change in length for a tapered cross section, for a tapered bar of a circular cross section. I hope you are getting this. That is a delta L is equal to 4pl by pi e d1 d2. If you like this video, comment, share with your friends and subscribe.